Okay, the last part of the lecture on software quality. So now we're going to look into product transitions, where in cases where we need to port our system to another environment. So there are three quality factors, which are portability, reusability, and interoperability. So the first one is portability. So requirements then to the adaptation of a software system to other environments consisting of different hardware, different operating systems, and so forth. Okay. So for example, your system is already implemented using Windows. Now you have to port it to another operating system. Okay, so to make it possible to continue using the same basic software in diverse situations, or to use it simultaneously in diverse hardware and operating system situations. For example, a software package designed and programmed to operate in Windows 2000 environment is required to allow low-cost transfer to Linux and Windows NT environment. The second one is reusability. So requirements deal with the use of software modules originally designed for one project in a new software project currently being developed. So sometimes some part of your modules are able to be used in other parts of the same system or another system. So you can make use of the existing module, because this can reduce a lot of effort, cost, and time. And at the same time, these modules, it has been tested, so that means you can also reduce the effort on testing. Okay. The third one is interoperability. So requirements focus on creating interfaces with other software system or with other equipment firmware. Okay. For example, the firmware of the production machinery and testing equipment interfaces with the production control software. An example given here is the firmware of a medical laboratory's equipment is required to process its results according to a standard data structure that can then serve as an input for a number of standard laboratory information systems. So that means the output from your system may be an input to another system. So they must be interoperable. They must have this feature in order for them to be interoperable. Okay. For example, your data is stored in student information system. It must be interoperable with other systems, because they are going to read your data from the student information system. So we have seen these quality factors from the three categories: okay, product operation, product revision, and product transition. Another representation another quality model that is also popular is Gavin's quality model. Okay, you can see some of them are already mentioned in the McColl's model, but they don't have kind of category to differentiate some of the quality factors. And we also have ISO 9126 standard quality model. So ISO also define a series of quality factors. Okay, so depending on what kind of project, sometimes you are bound to follow certain quality model based on certain needs, maybe from the stakeholder or maybe from the management. Okay, and now we're going to look at the challenges. Okay, so one of the challenges in terms of software quality is that generally quality dimensions and factors are not adequate for assessing the quality of an application in concrete terms. That means whenever they define the software quality, the quality attributes, the attributes to measure is not sufficient to assess the quality. So project teams need to develop a set of targeted questions to assess the degree to which each application quality factors has been satisfied. Sometimes subjective measures of quality, software quality, may be viewed as personal opinion. That means you think that you have achieved those quality attributes, but you don't have any evidence to support your claims. Software metrics represent indirect measures of some manifestation of quality and attempt to quantify the assessment of software quality. So, software metrics is an area in software engineering that comes out with the area to what kind of measures that can be used to measure the quality attributes, so that you can quantify the assessment of the software quality. So the dilemma of software quality is that if you produce a software system that has terrible quality or low quality, you will lose because no one will want to use it or buy it. If on the other hand you spend a lot of time, okay, and a lot of effort and huge sum of money to build the most perfect the most highest quality software, then maybe it's going to take a long time to complete, and it will be so expensive that people won't be able to buy or cannot afford to buy it. So either you miss the market window because you take too long to complete it, or you simply be exhausted with all your resources. So people in the industry is trying to find out what is the best way to handle this, where the product is good enough not to be rejected right away, but also not the object of so much perfect that you have to put so much effort and time and cost to complete. So it's like a balance between these efforts. So they come up with the term good enough software. That means it can deliver high quality functions and features to the end user. At the same time, it delivers other more or obscure or specialized functions and features that contain known bugs. That means you can produce, but at the same time you have some limitations. Okay, it is true that good enough may work in some application domains for a few major software companies. If you're working in big companies, then they have large marketing budget, so they can convince people to buy even the first version, because you can still improve it in the next version. But if you work in a small company where people don't know your company, you don't have a good reputation, then you may have to you may have risk that people may boycott your software later on. They will not buy your software anymore because of the first reputation is already tarnished. But you may never get chance to deliver the second version because of the bad reputation. But if you work in certain domains, okay, application software that is integrated with hardware, okay, that you cannot afford to have any error, or your company may be having risk to be sued. Okay, so the cost of quality that we have been discussed in part 1 and part 2 and also part 3, they are not something that is for free. It has its own cost. Okay, so first it can be in terms of prevention. You try to prevent from happening, or internal failure cost. That means it has happened, so you need to fix it. Or external failure cost. That means from the outside, external, they can give feedback to your quality team. Okay, so in terms of prevention, you can have planning, okay, how you can improve the quality. Okay, you can have activities like technical reviews. So technical reviews is like technical person in your team will be in a meeting to discuss about certain documentation, specification, or any other issues. Or you can have proper testing, or you can provide training to your staff. Okay, in terms of internal failure cost, now the failure has already occurred. Okay, now you have to fix it. Okay, so fix who are the person who will be doing the repair or the rework. Okay, or who are the people who will do the analysis. So this all comes in cost as well. So if you are talking about external failures cost, so you may have like complaint resolution from the clients, or you can have product return and replacement, or you can have helpline support, or you can provide warranty. But everything comes with cost. Okay, so that's why if we can prevent any errors from occurring, so it's better to focus on prevention. So the relative cost to find and repair an error or detect defect increase dramatically as we go from prevention to detection to internal failure to external failure cost. So from the beginning, the cost is around maybe $139. This is based on the research. Okay, so it is still acceptable until you are doing coding. After that, you can see that if the error is found after coding, the cost to fix it will become much more higher. That's why if we can fix the error as early as possible, then we can try to reduce the cost. So quality and risk. People bet their jobs, their comforts, their safety, their entertainment, their decisions, and their very lives on computer systems. So that's why we have to make sure that whatever we try to develop, it must have this quality criteria. Okay, so this is an example of November 2000 at a hospital in Panama. 28 patients received overdoses of some medication during treatment for a variety of cancers. And the months followed, 5 of these patients died from radiation poisoning and 15 others developed serious complications. So it's actually caused by a software package developed by US company, which was modified by the technicians to compute modified doses of radiation. So you can imagine if you are responsible for this kind of problems. Okay? So negligence and liability. Okay, so whatever we want to achieve, okay, we want to make sure that we have the best of intentions on both sides, the developers and the customers. Okay, so the system is late, fails to deliver desired features and functions, is error prone, does not meet with customer approval. These are all potentially be litigation issues. Low quality software, okay, it can be from the delivery date, failure to deliver function that you are expected to do, or does not include customer expectations. Okay, and low quality software is easier to hack. That means it's not safe and can increase security risks for the applications once it is being deployed. Okay? So low quality software is also liable to contain architectural flaws as well as implementation problems. And when you talk about architectural flaws, and that means if you have to maintain, then there will be, you have to change a lot of things in order to cater the problem. So impact of management decisions. So it can be in terms of estimation, in terms of scheduling, in terms of risk-oriented decisions. Okay, so management makes a lot of decisions that can cause risk to the development team to take shortcuts. Okay, so these are things that we should try to avoid. And finally, achieving software quality. So because it has a lot of cost, it does not come for free. So what are the things that we can do to avoid to produce the low quality software? The first is that we have to have proper fundamental software engineering methods. Okay, so software quality is the result of good project management and solid engineering practices. So that means in order to build high quality software, you must understand the problem to be solved and to be capable of creating quality design to conform with the problem. And whatever we can improve, we can reduce or we can eliminate errors from the beginning. We have to do it as soon as possible. The second one is in terms of project management, that we have to plan properly for quality activities. The third one is quality control. Okay, we have series of inspections, reviews, and tests to make sure that we are conform to the work product. The fourth one is quality assurance. So what are the activities that we can do in order to provide management with data needed to make proactive decisions before it's too late? Okay, so in this topic, we have looked into the software quality and the model, what are the challenges and achieving software quality. So with that, I end the